Another important skill is splicing wire. The simplest case is splicing two wires together. Splices always occur inside a box, and the box always must be accessible so that you can work on the wires later if necessary. Start the job by stripping the wires, removing about 1 inch of insulation from each wire. Hold the wires side by side. Grab the end with a pair of linesman's pliers and twist clockwise. Twist them together like a candy cane. Don't leave one wire straight while you twist the other around it. Cut off the end with the linesman's pliers or a pair of diagonal side cutters. Leave about 1/2 inch of bare wire, enough that the wire nut can cover it completely. Wire nuts come in several sizes. Select one for the size of wire you're splicing and the number of wires being spliced. Twist the wire nut clockwise around the wires. If you're joining solid wire to the stranded wire often found on light fixtures, roll the strands between your thumb and forefinger to wrap the strands together. Wrap the stranded wire clockwise around the solid wire so that about 1/8 inch of stranded wire extends beyond the solid wire. This helps keep the wires together as you turn the wire nut over them. Cap with a wire nut and twist it clockwise. Whether you're splicing stranded wire or solid wire, wrap the bottom of the wire nut and the wire below it with electrical tape. Though not required by code, it's good insurance against the nut slipping off and exposing the wires. Screw terminals on switches, outlets, and other devices make for reliable connections for the wires attached to them. Many devices have holes in the back for connecting wires quickly. A strip gauge shows you how much insulation to remove, and then you just stick the wire in the proper hole to connect it. Most professionals don't trust this method. While it meets code, it's not as secure as connecting to a terminal, and it is neither that much faster or easier. To connect a wire to a screw terminal, strip about 3/4 inch of insulation from the wire. Grab the wire just above the insulation with a pair of long nose pliers. Bend the wire back at about 45 degrees. Move the pliers up about 1/4 inch and bend the wire 90 degrees in the other direction. Move the pliers up another 1/4 inch and bend a loop in the wire, leaving an opening just big enough to slip over the terminal screw. Wire bending screwdrivers simplify the job. Push the stripped wire between the screwdriver shaft and stud and twist the handle. Once you've formed the loop, unscrew the terminal screw until it gets hard to turn. Put the loop around the terminal. Squeeze the loop closed with a pair of long nose pliers and tighten the screw. The clockwise direction of the loop causes it to tighten slightly as you turn the screw and is required by code. After you've connected all the wires to a switch or receptacle, wrap electrical tape around it to cover the screw heads and any exposed wires. Sometimes you'll need to join more than 2 wires together. Code doesn't allow you to put more than 1 wire under a screw, with good reason. The connection is bulky, and at least one of the wires is bound to come off, leaving the others loose enough to come off too. The most common multi-wire connection is to the ground wire in a metal box. The cables need to be connected to each other and to the ground screw on the switch. Since you can't put 2 wires under a screw, electricians make the connection with a pigtail. Cut a bare wire 6 inches long, put a loop in it, and screw it to the switch's green ground screw. Cut another bare 6-inch wire and attach it to the ground screw in the box. Put the new wires and the cable's ground wire side by side, Grab the ends with a pair of linesman's pliers and twist them clockwise. Snip off the ends with linesman's pliers or diagonal side cutters, leaving about 1/2 inch of the twisted bare wire. Twist a wire nut clockwise around the wires and tape the bottom and part of the wire as insurance against the nut coming off. The rules change when you're working with a 240-volt receptacle. Make doubly sure the power is off. There is a lot of power flowing through the lines. Then, strip about 1/2 inch of insulation from the wire end, but don't bend a loop in it. The wire should remain straight. Loosen the screw, insert the wire in the hole, and tighten. Of all the wiring skills, stripping wire is the most basic. The simplest and most reliable tool to use is a pair of wire strippers. A series of holes above the handles is marked with wire sizes. Put the wire you're stripping into the correct hole. Squeeze the handles, twist, and pull to remove the insulation. Remove about 1 inch of insulation if you're splicing 2 wires together. Remove about 3/4 inch of insulation if you're going to wrap the wire around a terminal. You may see an electrician strip wires with diagonal side cutters or linesman's pliers. Leave that to the pros. Unless done correctly, which takes a lot of practice, you'll nick the wires, and a nicked wire won't pass electrical inspection. Sometimes you'll need to strip off the cable jacket, especially when doing new wiring. You can use cable strippers, which usually have built-in wire strippers too. Or you can use cable rippers, which have a single tooth that cuts through the jacket to expose the wires inside. When you're cutting off power to a circuit, it's good to have a helper. Have your helper standing by a light plugged into the outlet or the light you want to replace. Meanwhile, you go to the panel. Starting at the top left, cut off the power to a circuit by removing a fuse or flipping a breaker. Ask your helper if the light is still on. It may take some shouting or even walkie-talkies, but every time you cut power to a circuit, ask, "Off now?" A no answer means to restore power to the circuit and move on to the next. Keep working until you get a yes in answer to your question. Always test a circuit, but first test your tester in a circuit you know is hot to see if it's working. Be thorough when testing for power. Put a probe in each of the receptacle slots. In a hot circuit, the bulbs in the tester will light up. If they don't, check a little further. If a faulty outlet is causing the problem you're trying to fix, the circuit could still be hot. Test across the hot wire and the ground wire. A circuit that is hot normally will light up a tester put across these 2 points. Check across the white wire and the ground wire. A badly wired circuit may have power running through the white wire while the black wire is connected to ground. This is called reversed polarity, and you should have an electrician repair it. But don't stop with the cable. Cables running through a box can be on different circuits. One can be dead while the other is energized, and an energized wire can shock you no matter what circuit you're working on. This is a good time to give the wire an initial test with a voltage detector. If the tester tells you the power is off, carefully remove the wire nuts from the cable and test with the voltage tester. Making sure the power is off is the best way to avoid having accidents. Don't start work until you've tested and double tested everything.